show you what the advanced part is. So,
But I'll be reading
3
I'll be
logarithm
reading here.
base 10. I'm not going to put the base 10 because it's redundant. Okay, that's what I have. If it doesn't have a base, you assume that it's base 10. That's how it works, okay? So, first things you have to check. Do you have the same base on both sides of the equal sign?
Yes.
Yes, we do. So now, what is our problem? That ugly minus sign right there. But there's a rule that tells you that if the same base logarithm is subtracting, it means they are dividing. So I change that and I have, and if they're multiplying, you raise it, right? So I've got logarithm of 16 divided by 2, which we know is 4.
And then you can
Not
cross out both logarithms.
Not 4, 8. Okay, so I've got,
Cross out.
very good, because I've got logarithm, I can apply anti-logarithm on both sides, and I'm left with 2. Okay? Could that be any simpler?
No.
Nothing. So you put two things together. So far, you'd only been simplifying and putting everything in one single logarithm, and you've been solving very simple logarithm equations. Now you put them together. See another one. It's easy, right? That's the way I ask. Okay. Logarithm base 7 of x plus 1 plus logarithm base 7 x minus 5 equals 1. What's the first thing you notice that doesn't let you work it easily? The 1. What am I missing? You're missing the logarithm on this side. The cool thing is I can turn any number into a logarithm of the base that I want. So how could I change this 1 into a logarithm?
Raising it?
No. Do you remember what a logarithm is? It's an exponent. So it's telling you that this is the exponent.
Like 1,
So
7 over 1.
almost. Logarithm base 7 of what?
1.
X plus 1.
No, because if I put a 1, then this would be logarithm base 7 of 1 equals 1. That's not true because this would be the base to the 1 equals 1, and that's not true. You've got to make it so it equals 7.
7, so then
I know the exponent is 1, so this is,
Logarithm 7.
so logarithm base 7 of 7. Because this is my answer, remember? Oh, so now it makes sense, and you put logarithm base 7 of 7. A 1, this is a 1, right? Because 7 raised to the what gives me 7? 1. Okay? Yeah? Okay. And on this side, logarithm base 7, multiplication. Very good. X plus 1, x minus 5. So these finally go away, and I've got that x squared minus 5x plus x minus 5 equals 7. And you can take it from there. You're going to have two answers because it's a square, it's a quadratic equation. Okay? Let me do one more. Now that you've got the concept of the 1. Two logarithm okay, what's my first problem here? The 2. What do I do now? 2 is not in a 1. Huh? Okay, so I know it's logarithm base 3 of 3, but I need a 2. This is a 1.
6.
No.
9.
1 times what gives me 2?
2.
2 times 2. Because this is a 1, isn't it?
Oh my god.
Isn't that like awesome? Cool. Okay, so on the other side?
You divide
I divide what?
2 over 2x.
No. It's not 2. 2
Oh,
is multiplying.
X squared.
X squared over x minus 2. Okay? So now what?
You multiply.
I can't cross out yet.
You multiply
Oh,
2 times
two.
x times 2. Make x minus 2.
3 squared in the logarithm 3, yeah.
Logarithm base 3. Say it how it is. Base 3
3 squared.
squared. Now I can get rid of the logarithm. And you go on from there. I think you can take it from there. Right? Pretty easy. It's cool, isn't it? When I discovered it, I was like, this makes sense. Okay. Now, based on this, we're gonna go to something the book calls, what's the color of the White House? What's the color of the White House? Duh, right? So, we have 42 logarithm 42. I'll do this one. 5 raised to the logarithm of 5. This would be just 14.
Because it's 1.
Okay? So, if they give you 42 logarithm base 42 of 5, 5. Just like the color of the White House is white, right? Okay, so if I have, hopefully it'll give me something longer so I don't feel so. Okay, try this one. This one complicates it just a little bit. To the 4 logarithm base 10 of square root of 3. What's the first thing you have to do here?
You put the
The
4
4
to
to
the...
You raise the 4 because it's multiplying the logarithm, so you work exponents first. And I still have the 10, but I'm going to have logarithm base 10 of square root of 3 to the 4, which we know is 9. So this one could go away, and I've got 9. Okay, forget it. Square root of 3 to the 4. 3 to the 4 over 2, because 3 squared, 9. Yeah? One more, one last one, just to make sure that you understood the concept, which you did. Better than any other class I've had, by the way. Okay. 3 logarithm base 3, 4 plus logarithm base 3 of 5. What do you have to do first? Multiply the 4 and the 5, so this would be 3 logarithm, so that you have one single logarithm. 20. Now, so this is 20. Easy, right? It's cool, I know. What about this? Logarithm base 5 of 25. Ooh. You have to do something first, because in order to be able to cross out or get rid of something, it has to have, it's got to have the same base, right? So that you can get rid of this. So this, first you turn it into this. Which would be this. So I go backwards. Now you get rid of it. So it's 2. Yeah? We good?